Well, it looks like the number of people coming in has reduced to a trickle, so we'll go ahead and get started, I guess. This talk is deploying a bare metal cloud is hard. And just to start off, who here actually operates bare metal? Awesome, a good number of the crowd. So my intent is to keep this high level. If you have a burning question, please feel free to interrupt me, and we'll just kind of go from there. I don't deep dive into anything super specific because everyone's environment is different, and that's something we do need to keep in mind. My name is Julia Krieger. I'm a open source developer advocate at IBM. And OK. There we go. So a little about me, so everyone has context. I've been an Ironic contributor since early 2015. I'm an Ironic core, and I was recently elected to the technical committee. I wrote a little toolkit called Bifrost, which seems to make some people happy in the world. So it's basically using Ansible to drive Ironic installation and deployment of bare metal machines. And I know the pains of deploying bare metal because I've actually worked in data centers. I've deployed servers myself. I've racked, stacked, cabled, all the fun stuff. Done the power calculations, the actual every bit of cabling. I've been there, done that. It's not fun. And I prefer purple bike sheds. So I'm just putting that out there now. So a common question I run across is people ask, why bare metal? And you do need physical infrastructure to build a cloud. So you need something to deploy your machines onto. Sometimes you want to do high-performance computing. You want to pay for the cost of a hypervisor or the memory mapping that reduces your overall memory available with a hypervisor. And I guess I'm jumping ahead because high memory. Some applications require so much memory that it just doesn't make sense to try and fit them into the box that we call virtual machine. In some cases, some organizations, some shops, some businesses have regulatory and compliance reasons that prevent them from actually running in virtual machines in public clouds or even virtual machines crossing tenant boundaries. So you end up in scenarios where you have to keep customer A on one physical server. So at some point, you either build them a cloud and a little island of a cloud to keep that compliance requirement, or you just kind of go, OK, physical bare metal, next. And at some point, you're either building a cloud or you're deploying bare metal. And a number of people do still build production-like environments for internal development. Those environments sometimes are physical bare metal because of all the above reasons. So I think everyone tends to at least imagine a bare metal deployment. It's kind of like this pretty beautiful road. Driving down the road and early in the morning, sun's coming up, and there are a couple twists and turns, and you can see it. But in reality, you don't actually see the rest of the road. You don't see what's beyond the hill until you're actually there. And my experience has told me, or taught me that it's more like traveling from airport to airport to airport to airport to airport, and then somewhere taking a turn to a left turn to Albuquerque, and then getting on another airport plane to someplace else. And every time you're at some place, you have to reevaluate where you're at, where you're going, and are you making the right business decision? So just for those who don't deploy bare metal in their spare time or deploy bare metal clouds, or just bare metal in general, you have some realistic basic steps. You unbox your hardware. You finish your base setup, which could be addition of like HBA cards if you have multi-million-dollar SAN environments. You usually start doing inventory and information collection, either manually or automatically. Somehow you have to get all this information, especially if you're running those multi-million-dollar SAN environments, because someone has to punch in those numbers. You usually also have to go and configure the baseboard management controller. How else are you going to manage the machine? Some hardware vendors make it very easy. Some hardware vendors, not so much. Then you have to connect all the cables. And that's usually where things start going a little sideways at times. Because then you have to go back and verify the cabling. You have to make sure your networking is correct, that everything is connected in the way you expect. And then you usually have to burn it in. And just a quick show of hands, how many people actually have run burn-ins on hardware that they deployed? So about 20% of the room, 15, 20%. That's actually really good to hear. My personal experience is if it doesn't fail in the first 2 weeks, it's usually going to live for a couple of years. But it usually helps to burn things in. And all those steps sound really easy. But in reality, it can be very difficult because you have operational constraints. You have things that prevent you from actually taking the simple path. You have those things above and beyond the hill. Imagine an operational constraint in your environment that says if you want a switch port configured, you have to file an individual ticket per port. And you have 4 or 8 physical ports that you must configure. Or an operational environment where you're required to have 4 network cables. And you don't know why. You're just told you have to have 4 network cables. This ends up becoming red tape. It ends up slowing your deployments, ends up complicating just every step of the way. And some institutions actually require that you have 2 people sign off on a paper checklist to verify that you have the right data. And in this day and age, we might think this is crazy, but a lot of this also goes back to compliance and auditing requirements that we don't think about in the current day. Because when you have a team of lawyers and accountants in a room, they want to see the sign-offs, they want to see the paper. They usually don't like electronic records because they can't implicitly trust in electronic records. They have to understand the system that those records are kept in order to be able to trust it. So I'm going to go through some common headaches, and we'll go from there. I mentioned 4 network cables. And in one case, this could be a constraint of you are required to use 3 servers. Some shops have such requirements. One shop I've worked in required 4 network cables per server. No one ever found out why we required 4 network cables per server. But 3 servers tend to take a lot of space. I mean, spreading your power across 3 power supplies could be useful, though. So a lot of times these requirements come from the way the business is operating and the way the business expects to operate. Sometimes there's not a good technological reason to do it. Sometimes there is. Sometimes one of the major pains is labeling. I don't know if everyone notices. There's no labels. There are no labels. And all those blue cables are inside the same cable management. How many people here have actually traced cable inside cable management? About 15% of the room. Awesome. Everyone knows it's a pain. And then some businesses require that you bootstrap or even deploy machines by actually connecting USB drives to servers. And there are cases where this actually sometimes makes sense. If you have secret data you need to move and distribute, okay, that's one case. But some businesses still require that you deploy every machine explicitly by USB drive or by using a disk. And that doesn't scale. I know of a vendor that actually has a significant bare metal fleet, and they had 30 people per shift managing their bare metal systems with thumb drives. They were a 24/7 shop. Their turnover was apparently staggering. And then the next fun thing about bare metal fleets is inconsistent hardware. This is actually a photo I took in preparation for the keynote at the last summit. And all these machines are configured identically. They actually had sequential MAC addresses. They're supposed to have identical configuration, logins, passwords. And some of them wouldn't actually even reply, just minor differences. So this is after I enrolled all the machines in Ironic. And you can see some Ironic has no clue about. Others, it thinks the power's on. And this is I just added the machines to Ironic. So that's one thing you have to actually plan upon, is inconsistencies in hardware and infrastructure. Some businesses actually expect VLAN tagging to be used throughout their infrastructure to the point where you're deploying trunk ports and expecting the server to know VLAN tags. Except you can't pixie boot with a VLAN tag. It expects no tagging on that port. So then you start running into, well, how do I do this? How do I get the information about the VLAN tag into that environment? And you end up in a scenario where you're just stacking things inside of other things and not even thinking about the overhead that you're building into your infrastructure. For everyone for context, every time you put a VLAN inside of a VLAN, you actually start losing the amount of data you can transmit, which is something you don't think about at a large scale, but when you actually need those 1,500 bytes to actually move to the next server, that becomes something you actually have to worry about because you don't want to fire hardware interrupts. But in the end of the day, when you're deploying a bare metal cloud, it's expensive. Hardware is expensive. It's a capital investment, which means people are involved. And sometimes, because of policies and politics within organizations, you end up in a scenario where anything becomes an act of Congress. I guess in short, I'm trying to say, here be dragons. But we have to keep in mind that a bare metal cloud is not traditional IT. It's not someone who went into a data center, installed a server, configured a server, and handed it over. It's a union of self-service and the infrastructure that exists. We have to also keep in mind that a bare metal cloud can support traditional workloads. But the processes that you take to get there have to adapt. They can't be the same processes you used 10 years ago. So there must be willingness to change. And a favorite little quote, which I have no idea where it came from, I can't seem to find it, is that you should not meddle in the affairs of dragons, for you are crunchy and taste good with ketchup. And it goes back to the issue of politics. When you're one person and you have a multi-million-dollar hardware order sitting on a loading dock, that's a lot of money for any organization to worry about and have to entrust to people and then processes and then get deployed. And it's very easy to become a snack of a dragon. So how to get things right? The very immediate thing you have to actually do is identify your needs, not your wants. People want to deploy the fastest cloud, the fastest infrastructure, the most reliable something. But do you really need that? Does your customer really need that? And that's something you have to go back and engineer into your deployment and your solution. How are you getting from point A to point B really matters. We might want the fastest thing, but we're not going to get it unless we actually need it. It's important to also treat these systems as their own islands in many cases. When you build an infrastructure upon another infrastructure, you become dependent upon the initial infrastructure. A good example might be DHCP servers. Everyone knows what DHCP is, hopefully? Address auto configuration. Well, if you build a cloud where everything requires that DHCP server, and you go to take that DHCP server out of service, what happens? Anyone? Eventually, the time to live expires, and machines lose their address if they're configured that way, and all of a sudden your cloud is down, and you're having a very bad day. So it's better to build these systems as isolated islands, or at least conceptually think about them as islands. When building these things, you also need to plan to walk through every ounce of the infrastructure at least once. You might have plans, build sheets, checklists to deploy these systems, to build the systems, but at the same time, you have to make sure that everything does work. The addresses that you have in your databases are correct. You can do this programmatically in many cases, but at some point, you have to make sure the cabling's right. And going back to those inconsistencies in hardware, they exist in every piece of hardware I've ever seen. I've received hardware where I have vendor A for a disk and vendor B with a disk in neighboring slots in a chassis. Not exactly what I ordered, but you have to operate with what you get sometimes. And if you have plans contingent upon the first vendor, and you weren't expecting the second vendor, that can cause other problems, depending on how you actually operate your infrastructure. The next thing that I really want to stress is that it's important to run current software. It's actually very difficult for the community to actually support software there are older releases. A perfect example is someone coming and asking for help with a Juno release of Ironic. That's a little hard for us to do. Things have changed quite a bit since Juno. We can do it, but at some point, we're not going to be able to fix an issue that you might have. The other thing that I would like to stress, and I know this goes against the grain of many organizations, but it's good to run what the community develops. Many packagers, vendors, keep downstream trees with additional patches. And those patches add up. And they could be small, opinionated little changes, but over time, over releases, you end up with different behavior that you have to keep account for. And if you don't know it, as someone that's deploying something, that can end up biting you. You could rebuild a system and all of a sudden find that you're not able to boot anymore because something changed. Because some patch disappeared. That was one-line patch. So running what the community develops does give you the ability to at least have that level of consistency and visibility. The other important thing is to engage with the community. It's very easy to go deploy bare metal cloud or an infrastructure and get it up and running, but then have a minor issue and have a fix. Well, if the community doesn't know this problem exists or this use case exists, then how can they prevent from or try not to break you down the road? So it's very important to provide that context because if we understand what someone's doing, then we can at least help them down the road. And truthfully, we do not read minds. If someone does, please let me know. I've got some helpful hints with Ironic. For everyone here, hopefully everyone understands, Ironic is an admin-only API, which is very different in OpenStack. Everything is considered for users. Ironic is considered as a service that other services call. You can have Nova-initiated bare metal and manually deployed bare metal in the same infrastructure. That's something to keep in mind. It's doable. It's actually very easy now in Ironic, but it's something that you have to keep in mind when you're operating, because you don't need 2 different deployments to manage 2 different systems. You can have one. Networking is always the biggest headache. Always. So a few expectations that Ironic has. We need to know about at least one network interface on the machine. We have to have a cleaning network. We have to have a deployment network. The cleaning and deployment networks can actually be the same network. From those networks, we need to be able to reach the API that Ironic offers. And the node needs to live on network afterwards. As I said, with the cleaning and deployment networks, these networks can't actually be the same. There are 3 networking models in Ironic that are worth keeping in mind. There's the flat pre-configured static networking model. There's the Neutron multi-tenant networking model, which allows for dynamic switch configuration, so you can actually have your bare metal servers on different networks. And then there's a no-op driver, which truthfully is just no operation occurs. And that module is used by standalone users. Now, it's important to actually note you cannot use the no-op interface with the other interfaces in the same deployment right now. Hopefully we'll fix that this cycle. It's a very minor issue, but it's one of those things, technical debt has actually occurred, and we just need to fix that. One of the fun issues that I've had troubleshooting is the claim for hardware iPXE support. Anyone here have servers with hardware iPXE? How many of them actually really support hardware iPXE? So 1 person, OK. So we had a couple of hands for iPXE support, and 1 person knows their hardware supports it. I've run into situations where the hardware advertises that it supports iPXE. You actually go to boot. It's actually gPXE under the hood. You hand it any iPXE configuration written in the last 4 or 5 years, and it explodes. System just doesn't boot. And those issues are the most frustrating issues to troubleshoot, and really requires pulling out tools like Wireshark and looking at what's actually occurring on the wire to troubleshoot it. The other thing to keep in mind with iPXE is iPXE does add new features. And one of the new things that we're starting to see is some hardware out there is only now booting to the network in UEFI mode. Hardware drivers. I'm sure everyone's deployed hardware or has hardware that requires some special driver. I tend to think of fiber channel cards specifically because they do need sometimes very specific drivers to operate. But in order for this to work with a system like Ironic, you need the driver in the deployment RAM disk that is used to write the image and the image that you actually write out to the server. You need that same driver there, otherwise you're going to run into problems. You'll run into things not working, or all of a sudden just machine not actually deploying. And this takes time to actually troubleshoot. So it's good to bake these things into your images, into your processes ahead of time. Another thing that is very important to note at this point in Ironic is we do have a concept of drivers and hardware types. And we're moving more towards this concept of hardware types. Previously, we had the classic drivers where the name of the driver would tell you how the driver operates and what it does. We would have the PXE IPMI tool, which would use iSCSI to write the disk image out. And then we'd have the agent driver, which would actually download the image, and write it out to disk directly on the machine. With our hardware types, that's changed. It's now, we have one hardware type called IPMI, and you can change the deployment interface from iSCSI to direct or vice versa, depending on your needs. I truthfully hate this next diagram. It's an ironic state machine. And it's complex. It may not make sense to someone that's new to ironic, but there are several steps that you have to jump through. And a lot of people don't think about some of these steps. The most mysterious step that people don't seem to really catch on to that often is our cleaning step. Because you can go in through cleaning, out of cleaning, so many different ways. So the next logical question that people tend to ask is, what is cleaning? Well, I'm going to start by saying, just don't turn it off. Just please don't turn it off, especially in production. And don't turn the power off to the machine if it's cleaning. I have a stack of dead hard drives at home that will never work again because we were scrubbing the disks on these machines when the power was cut. It's a very fast way to need to upgrade drives in your lab. That has to do with ATA secure erase, for those who don't understand. And with a lot of disk hardware, if you cut the power while you're changing the encryption key, the drive just never works again. Doesn't respond, isn't visible. It's dead. The other thing to keep in mind, what cleaning supports is the ability to, beyond wiping disks, is assert settings. We have a concept of hardware managers that actually can change settings or flash firmware. We are looking at supporting new ways of doing this, but this is the way that we support now to assert these settings. And they come from your deployment RAM disk. They're burned in your RAM disk. You can checksum your RAM disk and ensure that it hasn't changed. And you can have different RAM disks for different systems, depending on your operational needs. So the big question is, how do I troubleshoot this stuff when I'm trying to deploy hardware? There are a couple different things. We have a last error field. Sometimes it hides very well, but it usually gives you an idea of something bad has happened. A lot of times people think something's not working when a machine's in a wait state as well. The two things to keep in mind that you should check is the machine heart beating? Is it actually operating? And is there a cleaning step running? Going back to turning that power off with that hard disk in the server, if you're wiping those disks and you turn the power off, it's not a good thing. And we at least store that information if we're actively doing that at that time. We can't naturally provide progress because every hardware is different, but we do provide some visibility to that. If you're having issues deploying, there's also a feature to collect deployment logs, so you can go back and actually see, why did my deployment fail? A lot of times in the past, you'd have to run deployments and sit in front of the console and look and watch it. And for a moment go, there! It failed right then, and then the screen would go blank. So we now have the ability to actually download those log files to the conductor hosts so that people can investigate their failures. And one of the things that is important to really highlight is the ironic community exists to help people and help operators and make their own lives easier as well. So we don't have context to everyone's deployments. Everyone's problems are sometimes going to be different because you might have 2 network cables as opposed to 4 network cables with different configuration, different rules about how your environment operates that you've had to build into your infrastructure. So sometimes troubleshooting in an unknown environment is difficult. So we're here to help, basically. So any questions?
You've talked about the deployment of logs from the agent to ironic conductor. Is it a feature well supported, and from what version appear?
Sorry, the deployment of what?
Deployment logs. Sorry.
That's a really good question. The question is, when did we introduce the deployment logs feature in Ironic? I believe it was introduced in...
Like, is it a newer feature, or it's really old?
It's been around for a while. Okay. I believe a couple cycles.
I'm sure it was in at least Mataka.
I was thinking Mataka, but it might have been Newton when it landed.
Okay, because connecting to the host, VNC, and try to catch a log as they go is really painful, so the two guys...
That's extreme. Yes, it is extremely painful to try and troubleshoot systems, especially via VNC consoles. Any other questions?
What's the state of the art with IPA images? Last time I looked at rebuilding them, it was kind of a pain in the butt.
Rebuilding an IPA image? What's the state?
What new hardware drivers or whatever?
So there's multiple different tools to build an IPA image. Specifically in your case, are you using CoreOS or a DIB-based image?
So the hardware I was using wasn't supported by CoreOS, and I actually couldn't find an IPA image that would work for like base OS. For an IPA image that would work, I ended up using the Tiny Root stuff. That's abandoned now.
The Tiny Core IPA image?
No, it was the stuff Chris Martin was doing, the BusyBox embedded Linux one. Build root was on.
Oh, okay.
That appears to have been abandoned now.
Okay. The best way to actually build drivers into an IPA image is to actually use the Ironic agent element for disk image builder, because you can have scripts that are executed as part of building an image, or additional packages that you can pull in for whatever operating system that you're building this image into, so that you have that hardware support. So if you need multipathing, there's an element to help with that configuration, which also installs multipathing tools. So hopefully when your machine boots up, you at least don't have what Ironic thinks are 6 disks instead of 2 disks, depending on your pathing and your controllers. Does that answer your question? Any other questions?
For firmware updates, are you looking into things like LVFS to update the system firmware and device driver firmware, device firmware, stuff like that?
So there's a variation because we have many vendors and vendor support drivers. Our model right now is primarily to allow vendors to use or supply their own hardware type, or not hardware type, sorry, their own tooling to support their firmware updates. So ILO driver has the ability to have out-of-band firmware submissions so you'll end up with the firmware being updated out of band, whereas the standard use model that most other operators and systems deploy with are hardware managers that run inside the deployment RAM disk, so that when you go through cleaning, you can have those files in that RAM disk and have whatever scripts you need to actually deploy update firmware.
Having a firmware update element in the cleaning image, if you're generating it via DIB, would be a good way to go for that?
It would be. You would essentially end up with what's called a hardware manager for IPA to facilitate those firmware upgrades. And there's some wonderful examples that Rackspace put together that show how to do that. Any other questions? Guess not. Thank you, everyone.